Hello everyone, in today's video, we're going to experiment viewing tools and MCP tools in Google ADK for Java. Here's what we're gonna go through today. First of all, initiate a Java project from scratch. We're going to create an empty Java project, then add Google ADK for Java dependencies. Finally, we're going to provide Google API keys as environment variable for the dev UI server. Secondly, we're going to experiment viewing tools. Not that Java only supports Google Search and code execution tools within the current version we're using 0.2.0. There are also some limitations with the current version as well. We cannot use the built-in tool along with other tools, like function tool in the last video and MCP tool in the next few minutes. So here, Google Search Tool is a built-in tool. Your custom tool is a function tool, so it's not gonna work. Next one, built-in tools cannot be used within a search agent. For example, we have a search agent that leverages Google Search Tool, which is a built-in tool. So we cannot use this search agent as a sub-agent of another agent like root agent here, similar to coding agent, because built-in code execution tools is a built-in tool. Okay, so what we're gonna do in this section is pretty simple. Create a Google Search agent that leverage Google Search tools and test it with the dev UI server. Last one is also the most interested one, MCP tool. We also have a note here. This feature is not stable yet. We're using a very early version of Google Java ADK 0.2.0, so there's still a lot of things need to be improved. Most of the time, it won't work with the web UI server. That's why we will test our agents in the main method, like we did in the first getting started video. So in this section, we're gonna connect to an STDIO MCP server as well as SSE MCP server. In each type of the MCP server, we're gonna create an agent that leverage MCP tools and test it to see the result. Alright, let's go ahead and create a project. As usual, start of string.io. Redot or Maven depends on your favorite. Here I'll stick with Redot, Java, Spring Boot version doesn't matter, we'll delete it at the end. I'll name it Java ADK Demo Java 21, and let's download, unzip, and open it using your most productive IDE. Here I already opened it with my IntelliJ. Then we're gonna delete Spring related stuff, like in the source folder. I'm going to delete this class. And result, just delete the attribute, and in the test folder I'm going to delete this one as well. Here it's in the build of Redot, we don't need Spring here, only Java is enough, and I'm going to delete all stuff here. Okay, now let's add the Google ADK for Java dependency here, and a task for running the web UI server, the ADK web server, which is pointing to the agent package. Okay, reloaded. Alright, let's run our web UI server. Localhost 8080. Core is running, but we still need a Google API key. So we can go to aistudio.google.com and get API key here, and we can create a new API key here. Here I'm going to use the key we generated in the first video. Let's back to our edit configuration, and here's the task, and I'll paste. So here you can see Google API keys, and here is our key. And we also need to add another environment variables. Here is Google Gen AI use Vertex AI false. Okay, applied. Alright, the web UI server is ready. Let's move to the next step and create some agents. Here's built-in tool. We are going to create a Google Search agent. Let's create it under the agent bucket. And then let's go to the documentation. Here's built-in tool. and we're going to copy it as a professional copy-paste developer. So here's is Google Basic Search Agent. Okay, let's copy it. And we have a root agent, so it must be root agent and public static, right? And let's rename the name should be search agent. We also provide the model, the description, and instruction as well. And in the tool, let's new Google Search Tools. That's it. Let's rerun our web UI server to confirm our agent is functionally working. Okay, now we have loaded one dynamic agent, Google Search Agent. Let's go to refresh. And now we have Google Search Agents. List down all latest news about Google ADK for Java. Okay, cool. We have some results, right? So we take a look at the event and we see it in the request. Then we have our user message here and the tools Google Search. And here's the response. Very cool, right? So if you find it interesting, let's give it a try yourself. Now let's move on to the last part of our agenda today. MCP tools. In this section, we'll leverage the CoinGecko MCP Server for our experiment. CoinGecko MCP Server. You can find it in the link here. Okay, let's start with STDIO MCP Server. Let's create this STD CoinGecko agent. And then the main method. Because we're going to test our agent inside the main method, right? Let's start create an agent first. So similar to other agents, we create an LLM agent with the name model. So here we'll stick with 2.5 Pro for a little more intelligent. The description and instruction. So the only difference here is MCP tools. We need to provide tools which is MCP tool here. So how do we create them? Basically, Google ADK supports a class called MCP toolset. New MCP toolset. And this class requires a server parameters instance. So in order to initialize it, we need to provide a server parameters here. So similar to this configuration, MCP configuration file here, and obviously we can take this configuration file to connect to the MCP server from various MCP clients like Plot Desktop, Cursor, etc. And this is also the server parameters in our Google ADK. Let's create a corresponding server parameters for that. So for example, let's try to copy it a little bit. So we're going to create a server parameter here, parameters dot builder, and we can pass the command here. So command npx, and then we're going to add the argument. Here's just followed the arguments block here. The first one is MCP remote, and the second one is the MCP API CoinGecko.com. So we have the argument, and that's it. Let's build server parameters. So now we have the server parameters that similar to the configuration files here. Okay. So now we can pass the server parameters to our MCP toolset. And if you notice that the MCP toolset implements auto-closable, so it means that we can put it in the try with resources block. So the connection will be automatically closed when everything is done. Then from this, we can get the MCP toolset. load tools. This will return a completable future MCP tool. Let's locking get it so we can have all the MCP tools. Get 1 minute. Here, CoinGecko MCP Server support 46 tools, but to make it easy for the model to reset, we only specify 2 tools here in the instruction. Okay. Okay, let's bring them out in case they're errored. Now we just need to assign these two to our agent. Okay, let's put our agent inside the resource block as well. And tool now MCP tools. Right, that's all we're gonna do. Now let's go ahead and test it like we did in the getting started video. So we will create a section servlet, initiate a section format, and then a runner, and use it to run a section along with a user method. Okay, let's try to run our main method to test it. So we see here, create a connection to the MCP. So we see it's going to create a connection to the STDIO MCP server from our server is the MCP client. And okay, the API key for Google API key. Okay, we have to specify the API keys. Let's copy the Google API key to a main method here. Okay, apply it. And let's try to run it again. So you see, we call a list of tools, and then you're going to use the tool code to get the user message. Here we going to ask what is the current price of Bitcoin in USD, right? And then we see the result. The current price of Bitcoin is this number. Okay, it means our agent with the MCP tools is successfully working. But you note most of the time the configuration files require environment variable like this. So similar, there's a second way to connect to the MCP, the CoinGecko MCP server. Then we can use a local server, which is required API key, and you can put the API keys into the environment variables, right? Something like that. And we can also do it with the server parameters. For example, here I'm going to use the demo API key. So that's why here's the environment should be CoinGecko demo API key, and CoinGecko environment is demo. Okay. Okay. Now we're going to, let's say it's one, and this is the second one, and npx, so npx, and the argument is this one, is that. And then we're going to add the environment variable here. So I can add it, add environment variable, CoinGecko demo. This is what I have. And CoinGecko environment demo. Here's if my demo kit. So you see, we're going to create a corresponding server parameters for this configuration file. Then we can simply delete it. Okay, let's say now we're using the second one as well, but let's add some comment. So there are 2 ways to kick off the STDIO MCP server in CoinGecko. So this is the first one, serverless, keyless, and this is the second one, API key required. Then we're going to use the second server parameters to connect to the MCP servers is running in our localhost. Okay, this one. And let's try to run it to make sure everything's still working. Now we're going to use the second server parameters. You see it? So here is all of the tools, 46 tools here. And we are, to make it similar, we only specify 2 tools, the get simple price and get search trending. Get search trending and get simple price. Okay, and finally, yeah, we got the current price of Bitcoin, as we are asking for the current price of Bitcoin. Okay, let's do the same thing for SSE MCP Server. So it's pretty easy. Basically, let's copy the STDIO, but now I change to SSE CoinGecko agent. So here's the only difference is instead of create the server parameters, we going to create an SSE server parameters. And we need to provide URI. So you see the UI here and have the URI. And that's pretty much it. But yeah, we can also provide the timeout. This is the request timeout and the red timeout with the header. Okay. So here we defined the request timeout is 10 seconds and the red timeout is 30 seconds. So as you see here, because if we're using this URI, they are keyless and public. It means that we don't have to specify any header here to bypass the MCP server. But in most of the time, like you will need to have some API key or some bearer key to bypass the MCP server, so you can pass it in the header here. Okay. And here's our SSE. Let's say SSE CoinGecko agent. And we're going to pass our server parameters here. Okay, everything remain unchanged. And that's it. Let's try to run it. Okay, but we also need to add some. Okay, let's run it first. It will fail because we don't have the Google API key, but now we add it later. Google API key, apply. Okay, API key. Okay, now let's run it again. So you can see it's not working this time. Let's try to run it again. You know, like we already said from the beginning, it's not stable yet. Okay, it's time. The calling, the function calling to the MCP tools is success. There are also some function response, right? So the function response is the price of Bitcoin, but yeah, it's still not gonna work because the Gemini model should return the final result for us. But we know that the tool is called and our MCP tool is working. The final result is not completed yet because like I said, the library is not really stable. Anyway, let's try to ask another question. What are the top 3 trending coins on CoinGecko right now? Okay, I hope it's okay. Let's try it. Okay, after a lot of attempts to try running our MCP tools with a public API. So you mean public API, there's a lot of limitation with the public API, public and free API. But finally, we got the final result. So here's the top 3 trending coins, Wikicat, Bitcoin, and Ethereum. So you can see the function code request from the LLM, and this is the function response from the MCP server. Alright, that's pretty much it. Thanks for sticking with me till the end. I hope you're excited to give this a try yourself. And if you enjoyed the video, don't forget to hit that like button and subscribe. It helps you discover more content like this and helps me connect with more developers like you. I really appreciate you spending your time here. See you in the next video. And as always, happy coding!